Hey everyone, hope you are doing well. In this video, we will learn about Git Rebase. So if you want to make your work easier and impress your team with cleaner commit histories, you're in for a treat. We will explore what Git Rebase is and how it can help you to maintain a tidy project timeline, also resolve conflicts efficiently, and ultimately enhance your development process. So just grab your favorite snacks and get ready to level up with Git. So what exactly is rebasing? Well, imagine you are working on your project and you have got two branches. Let's call them master and experiment. You have made some commits on both branches and now you want to integrate them. That's where rebasing comes in handy. Let's understand with an example. Picture this, you have got your master branch and your experiment branch. You have made some commits on experiment branch and now you want to bring those changes into master branch. So instead of the git merge, where git creates a new merge commit, rebasing allows you to apply the changes from experiment onto master, as if they were made directly on the master branch. It's like rewriting history to make it cleaner and more linear. What's the difference between Git Merge and Git Rebase? So if you have been following along, you probably know what a commit is and what commit history means. But if you are new to this, here is a simple breakdown. A commit is like saving your work using the git commit command. And commit history is just a list of all the saves that you have made in the past. Now let's talk about Git Merge. Essentially, Git Merge does the same thing. It takes the commit from, let's say, our experiment branch and adds them to the master branch or any other branch you are working on. So what's the main difference in Git Merge and Git Rebase? Let's say you have got an experiment branch and a master branch and you have made some commits in both. So now when you are done with developing your experiment branch, we need to get the experiment branch back into the master branch. So for that, we have few options. First is Git Merge. With Git Merge, Git will create a new merge commit that ties together histories of both branches. You can just imagine this merge commit looks like a knot, which tells us this experiment branch and master branch are tied up together. So your commit diagram or graph will look like this after using Git Merge. Now if you're using Git Merge a lot, you will end up with lots of merge commits. By that, your commit history would look messy and your graph may end up looking like this, making it challenging to trace back any of the commits. Another option is Git Rebase. If you choose Git Rebase instead of Git Merge, here is what happens. When you want to move experiment branch commits to the master, Git Rebase takes all your experiment branch commits and neatly places them on top of the latest commit in the master branch, creating a more streamlined and organized history. In Git Rebase, Git does not create any merge commit. Instead, it changes the base of our experiment branch to the latest commit on master branch and then replays our changes from there. And that's the difference between Git Merge and Git Rebase. If you like taking notes, here is something special for you. This chart will help you to see the difference between Git Merge and Rebase. Now there is one more option. Instead of using Git Merge and Git Rebase, you can use squash commits. When you use squash, all the experiment branch commits, they are combined into one single commit when merged into the master branch. This keeps the master branch history linear, similar to rebasing, and creates a single merge commit. However, just remember that squashing will lose the detail of individual experiment commits in the master branch commits history. So if you ask me the difference between squash and git merge, here is a simple breakdown. Git merge combines the changes from experiment branch into the master branch and preserves the full commit history of the experiment branch. This means all the individual commits from the experiment branch are retained and a new merge commit is created to link the histories of both branches. Squash commits combine all commits from the experiment branch into a single commit when merging into the master branch. This process does not preserve the detailed history of individual commits from the experiment branch. Just remember that. So hope you have got this. As our topic is related to Git Rebase, let's see some of its benefits. Why would you use Git Rebase? The very first reason, you get clean and linear history. Yes, by this you create a linear history by eliminating unnecessary merge commits. Secondly, when you use Rebase, you are working on top of the latest commits from the main branch, means that your feature branch is always up to date with the most recent changes. Next, if you are regularly rebasing your feature branch onto the main branch, you can deal with conflicts a little at a time instead of all at once during a merge. This makes conflicts easier to manage. So these are the benefits of Git Rebase. Now, as every superhero has some kind of weakness, similarly Git Rebase has some demerits. So let's talk about few demerits that developers should be aware of. Conflicts can happen during a rebase if changes in your branch conflict with changes in the base branch. Resolving these conflicts can be tricky and time consuming, especially if there are many commits involved. One of the most critical rules of rebasing is to avoid rebasing commits that have been pushed to a shared repository. If you are not familiar with shared repository, here is the scoop on what it is. A shared repository is a central repository that multiple developers use and contribute to in a collaborative project. It serves as the main source of code and is typically hosted on platforms like GitHub, GitLab, or Bitbucket. Developers push their changes to this repository and pull updates from it, ensuring everyone works with the same code base. So, rebasing shared commits can create significant confusion for collaborators, leading to duplicate commits, lost changes, or a broken history that is hard to fix. After rebasing, you usually need to force push your changes to remote repository using git push f command. This can override other changes, which can lead to the loss of changes made by others. Rebasing rewrites history, which can erase the original order and reasoning behind changes. This makes it harder to understand the development process when looking back at the commit history. Okay, to sum it up, Git Merge merges a branch into another, preserving the full commit history and showing the branch evolution. Git Rebase moves or replaces commits from one branch onto the another, creating a cleaner and linear history. Squashing commits combines multiple commits into a single commit, resulting in a clean linear history, but it will lose the detailed commit history. So which one would be the best out of these three? Remember, you and your team needs to evaluate the pros and cons to choose the best workflow. And there is no single right answer. It depends on what's most important to you and your team. So that's all for this video. Hope you now have a solid understanding about Git Merge, Rebase and Squash and how they each differ. So thanks for watching. I hope you found it helpful. If you're still unsure, feel free to watch it again. See you in my next video. Bye.